Okay, very good morning to all. Today we are going to discuss about robo kinematics part 3. So it's basically a interesting topic, how to transform the body of the robo from one frame to the another frame. Either there are two frames in the robo coordinates. One is body frame, other one is uh, the one is body frame, another one is coordinate frame. That is, say, capital X, Y, Z. Say, consider hereafter in this topic, you consider capital X, Y, Z, capital X, Y, Z as a coordinate, the world space, world space. Small x, small y, small z is the point on the robo frame, robo body. Okay, point on the robo body. So we are going to represent the body frame and the robo frame with respect to one another each. Okay, so one another each. So if the point in the body frame is given, so say let P is the point. P is the point. It is represented P small P substitute of X, Y, Z. Okay, X, Y, Z. If P suffix of capital X, Y, Z is in a coordinate frame point, where capital P, small x, small y, small z is a point on the robo frame. Okay, robo frame. So how to represent what is the relation between these two? These are all the interesting topic. Only simple, you know, you're all very well interested in matrix analysis. So simple mathematics, taking matrix and determinants. So to transform, you have to convert it into inverse mathematics. So matrix and matrix inversion. So then matrix multiplication. These are all the simple transformation matrices. So suppose if a robo fixed in the frame, if the robo rotates, okay, the robo rotates in a particular angle. So what happened to the position, new position? So what is the translated position? Suppose if a robo moves along x-axis, the robo moves along y-axis, the robo moves along z-axis. So these movements are called translational movement. Okay. So if we rotate the robo about an angle of alpha along x-axis. So if a robo rotates an angle of alpha, say consider for x-axis alpha, y-axis beta, z-axis gamma. So for easy representation, we consider alpha, beta, gamma are the three angles along x, y, z respectively. Okay. So we need to describe in a compact and very easiest way of position of the position and orientation of the robo. Okay, so we basically discuss in the planar robos. We are not touch with the maximum three-dimensional robo. Okay, so these are all the things we are going to discuss. So let's see in detail. Clear? Robo kinematics. Clear? So here, see. So this is a body, a point on the body. So P. So this P represented by here small x, small y because two-dimensional. If it is three-dimensional, we can have x, y, z, right? So here only two-dimensional. Clear? So this is a point of the robo body frame. Say this is y, capital Y. This is capital X. So this origin. So here along x, xy is coordinate, body coordinate. So the small x and small y are the robo body frame, our body. So when we stand in a particular plane, so what is the what about the length we have along x-axis? what is the length along y-axis? That represent x and y. So at this x and y, say capital Y equal to small y. So that is the normal representation case. So at this point, so capital X equal to small x. Small x. Say this is the vector R. R vector represent pxy. So the R is nothing but say the pxy. Say R is a vector in 3-dimensional also. So xi plus yj. This is a vector representation. Yj plus zk. Okay, zk. Yj zk. Clear? So the R is the vector representing the any point on the body free. Any point on the body free. So if we rotate the body frame with the particular angle, okay, so we have to represent those things in the matrix format. See, the general representation of the transformed matrix, transform of x, y, z. Okay, so it is represented in a determinant format. So nx, oy, oz. Okay. Similarly, say qx, qy, qz. Similarly, or you can have another mx, my, mz. Okay. So we can represent the position, the transform matrix. Actually, the transform matrix consists of the transform matrix along with the position and orientation, So here, the relation between the body frame coordinate under the body frame matrix and the position and the coordinate axis. We represent say pxy, capital P x y z equal to the transformed matrix or simply a rotational matrix. If it is rotational, the transform matrix becomes only R of x comma alpha, R of y comma beta, R of z comma gamma. So these are all matrix representation of rotation. So the R of x comma alpha means the robo makes an angle of rotation. It displaces, angular displacer. Okay, so the robo rotates an angle of alpha along x-axis. The R of y comma beta means the robo makes an angle of beta along y-axis. Similarly, the robo makes an angle of gamma along z-axis. So it is a very simple representation of the matrix. Say alpha, say, let us see the matrices. So R of x comma alpha equal to, say, matrix. This is a rotation matrix about alpha, about x-axis, make an angle of that. So 1, 0, 0, 0 cos alpha sin alpha, 0 minus sin alpha cos alpha. Okay. Similarly, rotational matrix R about y beta, okay, which is equal to 1 here cos alpha minus sin alpha, cos beta, sin beta 0, 0, sin beta 0, cos beta. So 3 by 3 matrix of the rotational matrix. Next, rotation of Z comma gamma. Nothing but cos gamma minus sin gamma 0. Sin gamma cos gamma 0. Okay. 0, 0, 1. So these are all the three matrices represent in matrix format. When the robo frame makes an angle of rotation about alpha, so that alpha equal to that matrix equal to about x-axis. Sorry, here is minus. I will prove that also, no problem. This is plus. When it makes an angle of beta on y-axis, I interchange the coordinate. This is plus. Sorry, this is plus. This is minus. For z, it is correct. Okay, for z, it is correct. So let us prove how it happens. Okay, how this happens in the. For that, we consider the new two positions. Two positions. Let us define Px, Px, y, z equal to the transformed matrix of x, y, z into P small x, small y, small z. The Pxy is representation of a point of the robo in the world coordinate. Small pxy is a point represented in the body frame. Sorry. Say here pxy z is the pxyz is the point on the point on the world coordinate space. Pxyz is a point on the body frame. The relation between the Pxyz and the P small xyz is we can get the information of the robo. Say the robo in a, say you consider a robo in a Pxyz. So in a it is the P xyz is the point of a robo body. Say point of a robo body. When it makes a rotation or any translation or rotation, either the robo body can move translational. Okay, translation means linear motion. Okay, or the robo frame can rotate, make an angle, okay, with respect to their corresponding axis. If it moves in that way, so what is the point xyz? The point when it makes a rotation, what is the transformed matrix for the robo system? So that is very important. Here we consider a pxy. pxy body frame p small x y z equal to, it is represented at a point 1, when p1, say this is p1 of xyz, so it is xi plus yj plus zk. Okay. Similarly, the global frame or p capital X y z equal to capital X, or we can represent it initial p1 is, since it is p1, you can have it as y1 z1, then pxyz equal to x1i plus y1j plus z1, sorry, z1k. So these are all the vector representation for global frame. This is called a global, or you can call it as a global frame. This is called as body frame, say B or G. Okay, global frame and the body frame. So when I say previously, so the body frame coordinate of y, small y, and small x. This is global frame of x and y. So at when the initially when the body frame is coordinate frame at the one place, then this junction small x, capital X equal to small x, capital x1 equal to small x1, capital Y1 equal to small y1, capital Z1 equal to small z1. Okay. So when it makes to new position, say let us see in new coordinate. Okay. Say now initially p is at p1. Now it moves to another point. Say that another point is p2. So this is r1. So now the new point p2, it is vector representative of r2. So when it displaces one position 2, so body, a point on the robo frame is a p1 is displaced to p2. So which has a new vector representation. What is vector? Both magnitude as well as direction. So the new vector. So what happened when it moves to new position? Okay. So P2. Okay. P2 equal to capital X2 so now P2 of X, Y, Z equal to same representation. What is that? Capital X2 I plus capital Y2 J plus capital Z2 K. So similarly, P small x, small y, small z equal to small x2i plus small y2j plus small z2k. Okay. So this is the new vector. So what happened if the translational matrix happen? So if suppose if it is a particular angle, as I mentioned, particular angle. So what happened? Say let's see. Say this is a representation. Okay. So what is that? So initially the point is here P1. So now it is transformed to P2. Similarly Y1, Y2. So the initial point is rotated to the new point P. P2 is the new displacement. So the angle about Z. So this is the representation of this about the body frame rotates about an angle of alpha about Z axis. About Z axis. Actually, we discuss with three directional X, Y, Z. Okay. So we are whatever we are seeing in the vector diagram here. This is the representation of a planar body, planar robo with the two axes coordinate. So which rotates, which makes an rotation about Z axis, which we may not able to see, right? So it is rotating about Z axis. So when it rotates about Z axis, what is the representation? Okay. So in the X2, then for the P2, capital X2, when it transforms into from P1 to P2, so X2 is represented by I times it is capital I times, that is also this I is nothing but the vector of I, right? So vector of I, so the I vector is identity, so identity of X2, sorry, when it is right, the capital X2 is nothing but I2, sorry, I times X2. What is X2? I into X2 is, sorry, I times R2, because here, right. So I represented the vector of position P1. P is with the direction. P point is the represent of vector R. So R equal to xi, yi, j. So now we are going to estimate capital X2. So capital X2. So capital X2 equal to I into R2. So I into, what is R2? R2 is X2I plus Y2J plus Z2 small k. Okay. Similarly, we can write the relation Y2 equal to I into R2. Okay. I into, sorry, I is in the J, right? So J vector of R2, which is, so Y2 equal to J vector of X2 Ji plus Y2 J plus Z2 K. Okay. Next is Z, capital Z, the coordinate frame, capital Z. So what is capital Z? Capital Z2 equal to Ijk, K vector of R2, which is equal to K of X2I plus Y2J plus Z2K. Now, so this, see, when it is R1, the vector is R1 equal to X1I plus Y1J plus Z1K. Okay. Then R2, another, the new position P2 with the vector of R2, that R2 is X2I plus Y2J plus Z2K. Understand? So this P1 of capital XYZ, the P2 of capital X2Y, right? So the P2, the P1 is the position P of X1, Y1, Z1. So the P2 of position P2 is Px2, Py2, Pz2. What we computed here, you see, here is we computed X2 and Y2 because this is only two-dimensional frame. Okay, so the only because of that we just compute X2, Y2 and Z2 three axis. But here the Z axis, the Z axis, the body frame makes a rotation of alpha. we, sorry, we represented that is in gamma, right? So here, this gamma is an angle makes a rotation about z-axis, not x-axis, z-axis, right? So what happened to the frame? So when it moves to new frame, just you multiply this. So multiply uh, this I into this. Okay, you just we can make a sorry, p of p2 of x y z equal to, we will go to here. Here I represent I into capital I into I, okay, I into I of so here you see I into I of x2, I into j of y2, I into k of z2, I into I into I, sorry, it's not into dot product, I into I dot j, I dot k, I dot k, small x, small y, small z, x2, y2, z2. Here, what is that? Sorry, x2, y2, z2, x2, y2, z2. So here is j dot I, j dot I, j dot j, j dot k. Here k dot I, k dot j, k dot k, k dot k. So what is I dot I? I along x-axis, capital I also along x-axis. So I dot I lies on the, you see, here both, okay. So both this is this length, this x2 equal to x1. Similarly, here the displaces x1 displays to new x2 because of this position. Clear? So what happened? This alpha I along x-axis, I dot I equal to cos alpha. Whereas I dot j, it is negative, so it is in the negative side. So I dot j is minus sin alpha. I dot j, sorry, j dot I dot j, I dot j is minus sin alpha. Okay. Similarly, j dot I, j dot I is I dot j is minus sin alpha, j dot I, that is y axis. You see here in the y axis. So j dot I is plus sin alpha, j dot j is cos alpha. Remaining things are zero. You know what? I dot k, I dot k dot I, everything is zero, but k dot k equal to 1. K dot k equal to 1. So you substitute here, you will get x2, y2, z2 equal to, substitute here, I dot I, I dot I is cos alpha. I dot j minus sin alpha. I dot k 0. J dot I sin alpha. J dot j cos alpha. J dot k 0. K dot I 0. K dot j 0. K dot k 1. Small x2, small y2, small z2. So here this is nothing but P capital X Y Z. This equal to rotation of Z axis. Sorry, here also I made mistake. So I represent Z alpha. Okay, leave it. So the alpha here we consider alpha as a angle of rotation makes Z axis. Okay, this is Z axis. Right. So Z comma alpha into capital, sorry, small x, small y, small z. So this is the transformed matrix for z axis. Transformed matrix for z axis. Transformed matrix for z axis. Here I consider gamma. While doing the proof, I substituted alpha. Sorry, you just understand whatever may be. You can represent alpha or beta, but about z-axis means the angle is, the matrix is cos alpha or gamma. Either if you represent gamma, you can give it gamma, then gamma, gamma, and gamma 1. So this is rotation of z-axis about an angle of gamma or alpha, whatever may be there. But in the problem analysis, it is given as an angle 30 degree or 50 degree, 45 degree like that. So this is the transformed matrix. Okay. Next is homogeneous transformation. The homogeneous transformation, homogeneous transformation matrix H matrix H of X, Y, Z equal to that homogeneous matrix is a 4 by 4 matrix. So in the 4 by 4 matrix, first 3 by 3, the int elements. So the first 3 by 3 are transformed matrix. This is homogeneous transformation entirely. Okay, entirely. It is homogeneous transformation matrix consists of 4 by 4, 4 rows, 4 columns, 4 rows and 4 columns. Among the 4 rows, 4 columns, first 3 by 3. Okay, so this is either rotational or translational. Okay, either rotational or translational. The last column is consist of position Px, Py, Pz. Okay, so this is 0, 0, 0. This is nothing but the say you substitute as S. So S is nothing but a scaling factor. Scaling factor. Whereas P, this is a position vector. Position vector. So the relation between S and Px, Py, Pz is the suppose a point is represented by 10, 15, 30. This is the Px, Py, Pz. If this the scaling factor is 2, S is 2, then the value should be multiplied by the scaling factor of multiplication. You can have it as 20, 30, 60. Okay, Suppose if we have a 0.5, again suppose say 0.5, then again the new 0.5 or say 0.25, or say you multiply one more 3 times. We have 3 times, you divide, either divide or multiply, right? So divide or multiply, you will begin. Suppose if the scaling factor is division, okay, 2 by 2, then 20 by 2, 15, 30 by 2, 60 by 2. So this is the relation among the Px, Y, Z and S. S is the scaling factor. So for every translation, we have to find the translation homogeneous transformation matrix. Clear? So let us see simple examples. So first we see a simple example. You see here, the final position of corner P, final position of the corner P, that P point is represented by 5, 30, 10. X is 5, Y is 30, Z is 10. Okay. So this is the slab. This is the slab. Says for this is like a slab, or this is a robo. Okay, robo frame, like a slab, robo frame. Okay, instead of slab, you can also put a robo frame. Robo frame. After 30-degree rotation about Z axis, after 30-degree rotation about Z axis, okay, about Z axis, then followed by 30-degree about X axis, followed by 30-degree about X axis, then 90-degree about Y axis. Okay, can be found by first multiplying X, Q of the, first find the rotation of Z by 30 and the transformed matrix of 5, 30, 10 to get the new global position after the first rotation. Okay, so what is the, please let us do calculations. So first this P is first is first we have to find transformed matrix P, X, Y, Z. This is global. This is global. Whereas the point given is small x, small y, small z. Small z. So Pxy is a global. So P is, what is the relation between global and body frame? So the matrix rotation. If it is rotation, rotational matrix. If it is translational, translation matrix. First to find Z, comma, gamma into, see, this is a 3 by 3 matrix. So if 3 by 3, here the point given P is in a vector format, X, Y, Z. So the P XY, that is 5x plus 30y plus 10z. So we may not be able to multiply with row matrix because the row matrix is say 5, 30, 10. So we may not be able to multiply because this is 1 by 3. So if this and this will be same, if it is same, then only we can able to multiply. Then only we can able to multiply. That's why here we represent it is a, we have to take it as a transformed matrix. So what is transformed? It is, it should be right like this. Okay. So 3 by 1. So 3 columns and 1 row. Then this becomes 3 by 1. Then if here in this case these two are same. So when these two are same, we can multiply. We can able to multiply but the resulting vector should be of 3 by 3. Sorry, 3 by 1. Here 3, the remaining is 1. So finally we should get 3 by 1 matrix. Please understand this is a basic concept behind the matrix multiplication. So let's see what is the rotational matrix along gamma, cos gamma minus sin gamma, 0, sin gamma, cos gamma, 0, 0, 0, 1. Okay. 0, 0, 1. Now substitute this, substitute here cos 30 minus sin 30, 0, sin 30. Please do it. Calculate the values for this. Cos 30, 0, 0, 0, 1 multiplied by 5, 30, 10. Please calculate and tell me the value. So the robo frame makes an angle of 30 degree about Z axis. Then please tell me the value. Then it rotates about 30 degree about X axis and 90 degree about Z axis. 90 degree about Z axis. Please do it. After this, you find rotation of x alpha equal to, or alpha value you can write directly. How much? 30 degree about, followed by 30 degree about x axis. So you substitute. Okay, first write the formula. X axis, right. What is x axis? 1, 0, 0, 0 cos alpha minus sin alpha, 0 sin alpha cos alpha, sin alpha cos alpha. So now substitute the alpha values. Same, whatever you get here, that will be substitute, but the elements are displaced. Elements only displaced. So 1, 0, 0, 0 cos 30, then minus sin 30, 0 sin 30, cos 30. Okay. So rotation of x comma 30 equal to, please tell the values. Again, it is displaced by if you tell me the first answer, then only we can able to continue. Anybody? Please.
Sir, minus 10.66.
Why is?
Minus 10.66, sir.
Minus 10.666.
Yes, sir.
Okay. Why?
28.4.
28.4. Very good.
10, sir.
10. So now, first the robo body rotates an angle of 30 degree above the Z axis. So what is the new position when it makes 30 degree above the Z axis? So what is the original position? Original position is 5,
30, 10.
now it is displaced to the new position of that position. We will write here that P small x small y small z, sorry, you can write the P2 new position, P2 equal to we have to write like this, minus 10 minus 10.6 28.4 and 10 transform. Okay, so now the next step is the new robo frame makes an angle of 30 degree about x-axis. So we should substitute here 1 0 0 0 cos 30 is how much? Root 3 by 2. Okay, root 3 by 2 of minus of 0.5 0 0.5 root 3 by 2. Here you should substitute minus 10.66, then plus 28.4, then 10. Please calculate and tell me the new position, transform new position of the robot. Please tell me.
First one minus 10.66, sir.
P2 x y is equal to minus
10.66. 0.4 into
y
the partners.
19.59, sir.
19.59. Okay, 6 19.6.
14.2.
22 or 21?
22.8, sir.
22.8. Good. Now please do after this rotation, the robo makes an angle of 90 degree about y-axis. Okay. So what is the transformed position? Y-axis are y comma beta. Y comma beta equal to cos 90 cos 90, do it, cos 90, then 0 sin 90, sin 90, useless. Sorry, right, sin 90, 0 1 0 minus sin 90, minus sin 90 0 cos 90 multiply by this transformed position. This transformed position is substitute here, minus 10.66, then 19.6, then 22.8. Tell me the final position of the frame robo.
22.8.
22.8.
8.
22.8.
19.6.
19.6.
10.66.
10.66. Very good. So this is the calculation of frame position for different rotations. Okay, different rotations. Let's see one more problem. Please take down. Translate the vector Please, all of you do this. Very simple. Translate the vector P equal to 30K plus 30I 20J plus 15K. P is the point 30I plus 20J plus 15K by a distance of, okay, by a distance of 10 units, 10 units in X direction, then 8 units in Y direction, 8 units in Y direction, then 2 units in Z direction, 2 units in Z direction. Please do it. What is the homogeneous transformation matrix? So the transform of ABC, the transform of here, what we discussed here is the rotational. Okay, here rotational matrix about X, Y, Z. Rotational matrix about X, Y, Z. Whereas here is translational matrix. A point is given. This point is under robo frame. So 30I plus 20J plus 15K. So if the frame point on the frame, robo frame moves distance, that is distance of 10 units in X direction, 8 units in Y direction, and 2 units in Z direction. So we consider the points along X, Y, Z as A, B, C respectively. So what happened? Transform of A, B, C equal to, very simple. Okay, the transform matrix consists of X, Y, Z. So what is the translational matrix? 1, 0, 1. Instead of rotational matrix by 3 by 3, we simply substitute the unit matrix. Okay, 1 identity matrix. So 0, 0, 1. In this, this is the position. I already mentioned you. You see, what is that? You see, in the homogeneous matrix, this 3 by 3 is our rotational matrix. This is the Px, Py, Pz, the translational points along X, Y, Z, right? A, B, C. So this can be written, you can also put A, B, C, S. Same thing here. So here we put 10 points along. A value is here, 10 Px. Px is 10 units, yes, 10 units along X direction, on the 8 units along Y direction, then 2 units along Z direction. So 0, 0, 0, 1. There is no scaling factor given. So if scaling factor is not given, you simply take as a 1, value as 1. Understand? So please calculate and tell me. Sorry, multiply by the factor, the point 30, 20, 30, 20, 15, 1. Then only we'll get the translated matrix. So this is 4 by 4. This is 4 by 1. So since these two are same, so we'll be getting 4 by 1. 4 by 1. Please tell me the value 4 by 1.
55, sir, first one.
50,
5.
55. Wrong. What I am getting is 40, 28, then 17. One, check the answer.
Sir, first one matrix first row 10010 பதிலா 10110 போட்டீங்க சார். அதனால 15 ஆட் பண்ணிட்டேன் சார். 10010 வரணும் சார் அங்க ஃபர்ஸ்ட் ரோல.
Sorry. What you are
அதனால தான்
sorry. This should be identical.
Okay.
No, sorry. Okay. So you will be getting this answer. Okay. Next, you do one more problem, please. One point. P small xy. P small xy z equal to 8, 6, 5 translational or to be translated to a distance of 7 units along OX axis, 2 units along OY axis, and -3 units along Z axis. OZ axis. Okay. Determine using appropriate convention. Determine the homogeneous matrix. For new PXYZ. P capital X, capital Y, capital Z. Please do it.
15, 8, 2, 1, sir. 15, 8, 2, 1.
Very good. New value, right?
Yes, sir.
Good. So the answer is PXYZ equal to 15,
8, 2, 1.
8, 2, 1. Okay. Then suppose if we want to, we have been discussed about P capital X, capital Y, capital Z equal to the homogeneous matrix of P small x, small y, small z. Suppose in the reverse manner, suppose the pxy is given. So what about p small x plus small y small z? So the world's global parameter, global point is given. The robo makes a rotation or translation. So what will be the new frame, a point on the new point on the frame, the robo body? In that case, please remember small x, small y, small z. Then this would be the matrix, translated matrix or rotational matrix inverse of P capital X, capital Y, capital Z. Suppose if a robo are you hearing? Hello?
Yes, sir.
Yes, okay. So suppose a robo frame rotates about x-axis an angle of 30 degree. The coordinate points P, capital X, capital Y, capital Z equal to say 10I plus 20J plus 15K, assume. So this is the global point, the world space coordinate point is point in the frame. So what will be the new frame point? Okay, that is pxy, the position. So in that case, p small x, small y, small z equal to the r inverse of alpha, x comma alpha of capital X, capital Y, capital Z. So in that case, please remember the various inverse matrix of various inverse matrix. So what is the row inverse matrix for when robo rotates, robo R inverse of x comma alpha. R inverse of x comma alpha is 1 0 0 0 cos alpha sin alpha 0 minus sin alpha cos alpha, right? So this is the inverse value. Similarly, R inverse of y comma beta. So what is the R inverse? Cos beta 0 minus sin beta 0 1 0 sin beta 0 cos beta. This is R inverse of rotational matrix inverse of beta angle beta along about y axis. Similarly, R inverse of the z comma gamma. So here cos gamma sin gamma 0 minus sin gamma cos gamma 0 0 0 1. So this please remember the inverse matrix as well as the rotational matrix about alpha alpha angle about x-axis and y-axis, z-axis. Okay, so please let us do the rotational vector. A vector rotate the vector P, capital P equal to 10I plus 6J plus 16K by an angle of 90 degree about x-axis. So what is the transform matrix? What is the rotation matrix? Please tell me. homogeneous matrix. Homogeneous matrix or transformed matrix. One zero 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 cos 90 minus sin 90 0 sin 90 cos 90. Sorry, it's a homogeneous matrix, right? 0 0 0 here 0 0 0 1. So this is a homogeneous matrix because homogeneous matrix is 4 by 4. Okay, then you can multiply this matrix with the position 10 6 16 1. Finally tell me the answer. So h of x comma 90 of a translated point. So 10 minus 16 6 1 translational. So this is the framework translated position. Okay. So remaining things we will continue in next class.